Okay, in this video we're going to take a closer look at the InStep Studio 3D version 3.1 application. This will be specific to the Edit tab. What we're going to do is we're going to go through a few different examples and just kind of illustrate what the different tools do and some tips and tricks around those. So we're going to start off with just a very simple monkey geometry. So this is Suzanne from Blender. People that have used Blender in the past will recognize this. The geometry as it loads in is actually correct, so there's no errors with it. That's indicated by the green mesh. The application is set up, so if you go to application settings, you can pick manifold body color, which is this green, or a non-manifold body color, which would be a red or a red adjacent. That's just a quick way of checking whether the data that's being loaded in, if it's okay or not. It doesn't necessarily mean that the geometry itself will be feasible as a step file, but it does give you some very quick checks. So if I were to import a different one instead, this here is a clear open section, and you can see, it comes in as a red data set. So if we go back to our monkey, and by the way, you can just go File and then pick a recent geometry as a quick start, or you can also drag and drop into this field STL OBJ files, and that will do the same thing. So once the file is in, we get some basic information here. We see it's a relatively small file, so those are good as test files for sure. Go over to the Edit tab, and let's say we want to just modify a few basic items. So what we can do is we can turn on the edge mode. So Alt and E turns on edge visibility, just like Alt and V turns on vertices, and Alt and F turns on or off the facets. This makes it a little easier to work with these, just as a reference. So let's say for some reason we don't really like some of these triangles here, and we wanted to change something. We can just click on them, and then we can go up here and delete them, and that just creates this void. One thing that's important is when you do operations like this that actually affect the facet data, the application initially just does a display update. It doesn't actually delete it. To make those changes permanent, you have to either accept or cancel that. So let's say we did this and we're like, there's not something we wanted, we can just hit cancel and it'll undo that. The application in itself doesn't really have an undo option. There's something that's still in the works. It's probably one of the most requested features. The reason behind the undo option is it's actually very difficult to implement without just slowing the entire application down to a crawl. So some effort has been made in terms of previews, and then for some of this stuff here where you can just accept or clear it. But let's going back to the delete. Let's say we wanted to change these two facets. We can go in delete and then accept that change, and now we see it's got this shape here. If we wanted to just create two new triangles, so rather than the edge being across here, we wanted it to be diagonal, we can turn on vertices from the selection options as well, and then we can click. We probably want to turn the facets off to make this a little easier. Control click, by the way, unselect something. But it obviously has to be selectable first. So we unselect this, turn this off, and then we can go in and select 3 vertices and then create a new facet. One thing I want to mention is the order in which these vertices are selected is important. So it follows the right hand rule, meaning if we select this point, and you can see it goes red rather than the violet, this point here and then this point down here, these form what's known as a right hand coordinate system, meaning if we take our right hand and rotate it in the order of these points, the thumb points outwards. So the green side is the outward, the dark gray is the inside. So if we do this and click create, it'll create a triangle. The preview is light blue, but if we were to look at this from the inside, and I'll I'll use my spacebar for this, it's partially enabled. We can actually see that the inside is correct. Okay. Let's say we didn't remember that, or we weren't sure, or we've been in a hurry, and we create one that's left-hand oriented, so basically the reverse. So let's say we click this, we click, so right hand would be this, this, and then this. So let's go in and select this vertex and then this vertex. Okay, now we create a facet and we can't see inside anymore, but we're seeing the back side of it. So we go ahead and accept this, and now we're left with a triangle that's incorrect. Really quickly, another thing here before we correct this. If we want to change the rotation point for our orbiting, we can click on any facet with the middle mouse button. So if I click here, nothing happens initially, but we can turn on the rotation indicator with Alt and R for rotate. So we turn that on, and then we click, and then it leaves this little red dot. Now this becomes our rotation center. And we can set that anywhere. It has two effects. One, it sets the orbit center, and secondly, it also sets the zoom reference. So as we zoom in, the zoom actually slows down. The further we go, the slower it moves. And that's a feature, that's not a bug. The idea being that we can zoom in on small features more accurately than, let's say we back here, and now we zoom in, we just zip through it. Okay, so you can use that to your benefit. A spacebar, by the way, and you obviously can't see that, is a relatively useful tool. In this scenario, there's still a few things we need to implement in order to make that work better, but you can use it semi-effectively with this. Okay, so back to the triangles. We set the rotation point so we can properly investigate this. We can see the inside is what should be on the outside and vice versa. The way we can flip this is actually very simple. We select it, and sometimes you can't see from the outside when we select it, but we'll turn facets on, we click on this, and it turns red, and then we can go up here and say flip, and that's it. That's all there is to it. We can flip that triangle with a single button. Again, this falls into the category of visual only until we hit the accept button, and now it's part of the data. Okay, so that's the very basic way of editing facet data, and this can come in handy if you have a lot of data that's generally okay, but there's just very small details that need to be corrected. We also have the option of moving individual vertices, so we've got the modify edit vertex option. So this is a separate pop-up, and we can select the point, and you see it only allows us to pick active points. Let's say we pick this one, and now we have the coordinates of this. So I know this is XYZ coordinate, so if you want to move it to the left, we have to actually decrease the x value. So let's decrease it by, say, 0.1. Okay, we do that, click update, and now, oh, we had it wrong. We want it to go in the y. So we'll go back, we'll make this 0 again, update it, should probably make it 0. Update it to 0, puts it back there, and let's go y minus point A. And now we see the actual vertex is being moved. Unlike the other commands for the facet, this is being done directly. So whenever we click update, it actually does update the data. Okay, so that's just a word of warning. If we click cancel, it'll remain there. So we can go back and modify this again. Select, click that point, and then we'll just make this 7. Okay, so that's the modification of vertices, and sometimes that comes in use as a useful tool if you need to move stuff around. There's just small stuff that needs fixing. We can also go ahead and insert actual vertices, and here there's a little bit more detailed option for picking those points. So let's say we want it to be down here, and we wanted to just create a new vertex in here. We can just say We have multiple point options, but we can say between points, and then we pick point 1, click this one, and then it says down here pick vertex 2, so we know the first has been selected. It's not very visible on the green background, but we can click this one here, and now it gives us this point in between, and that's exactly in between. It's a factor of 0.5 along this line. We can change that up and down, or we can even go in and say, well, for each of these points we want more detailed points, so we do a point selection of a point selection. So we use this to bring up the same dialog again. Once we're happy with that, we click OK, and that inserts that point. And then, if we wanted to go in, we have facets enabled. We can delete these, for example, and then we could use this vertex as a way to actually construct new geometry. Make sure it's there. And then we create a new facet like that. That's a very useful way of doing that. Understandably, it's very slow, but in some cases this is the best way of doing that. Now, in the scenario like this, the application obviously doesn't do its own checks again to make sure that everything is fine. But we can go in and actually turn on the perimeters that are open with this button here. It's relatively difficult to see on a green background, so we can turn off the facets and just be left with edges. Now we can see that those edges are open. So if we were to export this, the output will still work. To conversion to a step file is okay, but the resulting data won't be a solid, it will be a sheet body. So let's take this a step further. Let's turn facets back on, and let's say we want to remove this entire section that forms the eye. We're not really enjoying this. We turn the facets on, we click 1, and then we have a few options of growing that selection. So we can do grow selection, which individually expands it, and it's always through the neighboring facets, so you see it starts spreading out. If we don't like that, we can click the escape button. That'll clear selections. We can go back in here and select one and then do a flood select, which brings up the dialog box that asks for an angle limit. In this case, I know 10 degrees seems to work pretty well. Click OK, and it selects all these. So the angle limit looks at two neighboring facets, their shared edge, and determines what the angle between them is. If it's larger than the value that we enter, it does not grow across that boundary. If it's smaller, it does. Note, if there is one that allows the selection effectively to leak out, it will continue on the outside and then may actually come back in. So that's just a word of warning. So we can go in, we can delete these, we accept that. And now let's work with the hole tool. So we have two different ways of fixing holes. We have the single fix hole tool, which is a little bit more detail, or we have the fix all tools. I should mention that the tools over here are more involved, so I'm not going to cover all of them in quite as much detail. These are essentially automatic tools, and I recommend against using them just because you feel like that should be the tool that works. Some of these can actually change the data quite drastically, and it can also take very long time to do. The automatic fix option is notorious for that. It can take very long for something to be completed. So only use that if you're familiar with it, and we'll cover that in a little bit. But for this case here, what we want to do is we're just going to turn the vertices and the edges off, just so we don't have so much visual stuff going on. And we're going to go and use the single hole option. This brings up this dialog box, and right away you can see the highlight open sections. So we can go in, we can select the boundary, and then we can hover over this and I'll actually highlight that section. It is a relatively intelligent selection option in that it finds out which edges are combined, so I don't have to manually select all of them. So let's go in and select this, and that's pretty much all you need to do as far as selections. If you have a hole with shapes on the inside, you can go in and also define cutouts. That's a little bit more involved and a little bit trickier, so I'm not going to cover it here. We'll save that for a second tutorial at a later time. But for now, we've got the boundary selected, and all we need to do is pick our closure method. Now there's tessellate, there's Delaunay, minimal, smooth and bounded. The one I generally recommend is either minimal or smooth. But let's go through and see what these different ones do. And some of them don't, or some of them are not guaranteed to work. I just want to make that clear. The algorithms themselves sometimes can hang up and things like that. But if we pick the tessellate, the first one, and do a preview, we actually see this one fails. It doesn't completely fail. It just fails in finding the orientation. So on the inside we can actually see the facets, and we can fix those just like we did before. So we're not gonna use that right now, even though this would actually be a fine closure method for this. Let's go back, let's try the Delaunay, and that does something similar, but in this case it's actually a lot worse. So it tries to interpolate the boundary edges, and it doesn't really like some of these sections. So let's skip that and move on to another one. We'll do a quick clear first. Let's do the minimal. This is probably my favorite. And it basically zigzags through the data and tries to find a minimum set of surfaces. In this case, this will be perfectly fine, and we could probably use that. We'll just show the other ones as well. So we've got the smooth option. Tries to maintain gradients, and in this case that might be a good option just because the perimeter isn't smooth and it isn't continuous. Or we can also look at the bounded, which is a iterative process, has some issues, and yeah, this is a case where it doesn't know what to do with the data. So let's go ahead and use the smooth option. So we like this, yeah, let's apply that, and we're done with that. And then we can go in and do whatever else we want to do with this. Okay. Now let's try the other side and do something similar, but use the automatic tool. So we're going to go in, we're going to select the facet, which is going to flood it with up to a 10-degree angle. And this might work at 15. I don't know exactly what the number is where it trips, but 10 seems to work fine. Delete this, accept it, and now we still have this left over. Okay, so if we were to turn on the perimeters, we can still see these are both flagged as sections. So we're going to go over here and do the fix all holes. Now basically the same algorithms are presented again, but it doesn't require us to go one section by another. So if you have a lot of holes in a geometry, then this is the more effective approach. However, we may also have a scenario where we only want to fix some of the holes, and usually it's very large ones and very small ones combined in a shape. So we can also turn on the max edges. In this case, I don't know, there's probably on the order of 50 to 100, so we can just say let's do anything above 20. Okay, and it goes only closes this because there's more edges than 20 in this loop. And we can probably find now roughly where that is. If we do 100, then it finds this as one as well. And again, we have the tessellate, we have the smooth option, minimal seems to work fine too. The bound is probably not going to work. No, it actually works in this case. The bounded, you can somewhat see how it works. It actually works from neighboring edges and tries to generate a triangle, and then it sort of steps around until it's filled it in. So it works around the boundary of it. So let's say we go with the minimal, or let's keep it the same as the other side. We'll do the smooth option, and we'll go ahead and apply that, and then we're back to having good shape. So let's import a different file here really quickly, just to see what some of these issues might look like. So we got this file open, and it's relatively obvious where the problems are. In this case, it's just an open section here that was not scanned or whatever it is. We can click on issues, and we can, if it isn't turned on, we can turn on the open edges, and that's essentially exactly the same as the perimeter. The perimeter often will work on temporary data as well, whereas the issues won't. So if you just want to see the open perimeters, this is the tool. If you want to have it run on all, then just go with the issues button. The open edges are just as defined. It means it's an edge of a facet that has only one facet attached to it. If the edge itself is collapsed, so both vertices are the same or something along those lines, it will show up as an invalid edge. And if two facets occupy exactly the same space, they might be flipped one to the other, it'll come up as a duplicate. Invalid features will be triangles that are collapsed to a line, or where all 3 points are on the same line, so they effectively don't define an area. Now, intersections will be turned off by default. The reason for that is relatively simple. This takes a long time. All the others are relatively quick to calculate, even on bigger models. The intersection is going to go through and actually test whether each triangle intersects another one. So only turn this on if you encounter some strange behavior, or you can actually see that data is not clean. We'll turn it on for this model because it's relatively quick, but it will still take a few seconds, and we can see there's 0 self-intersections here. Okay. The issue button down here, what it'll do is it'll go through each of these one at a time and actually just jumps to that location, so it makes it easier to see. So it says, okay, it's like this is an open edge, and it puts a marker at the center and it focuses our rotation point there. Let's see the next one. This edge is open. Okay. This edge is open, etc. So it'll go through and it'll show us all 55 open edges this way. That's maybe not needed in a case like this where it's simple, but if you have a very large body and there's one open edge or two in 2 million, this is a very simple way to actually see those without having to go hunt for it. Again, if we turn off the facet with Alt-V, we can visualize that a lot better. So that's the issues option. Now, let's go back and look at a few more things. We jumped over the measure, trim, and split tools. So let's take a look at those. The measure is also accessible up here if we're not on the Edit tab, as it is considered a pretty important thing for getting an understanding of what the data looks like. We click on this, we open up the measure bar, and it gives us the option to pick 2 points. We can select point 1, and it gives us the full detail for it. We can, by default, it's just going to be an existing vertex. So we're going to go ahead and turn on the snapping option and pick one from here. So let's just go in here somewhere. Click that one. That's okay. And it gives us the exact location for this. Now let's pick a second point. Same thing here. Snap. Top, by the way, just means this stays on top no matter where you move it. If you have emails pop up, this will stay on top of that. We can turn that off. We'll pick another point up here. And okay, and now we get this interesting display. So we have a blue line, we have a green line, we have a red line. This corresponds to red, green, blue, X, Y, Z. Okay, so this is the X coordinate, this is the Y coordinate, this is the Z coordinate or Z coordinate. The white is the direct line between them, and the other three represent the coordinate offsets, which are also given here. Again, we have point 1, we have point 2. These are the coordinates within the data, and these numbers will be affected by any scale that we apply. So if you haven't seen how to apply a scale, go back and see the previous video about import. And then this is the linear distance between these points. If we want to do some more advanced stuff, we can turn on multi-point statistics, and this will allow us to select a lot of different points, and they'll just show up as a list of points, which we can export if we want to see it as a file, but we'll also get statistics about it. So if we close out of this, we see this is centroid of all those points. If a plane were to be defined through it, there's a point on the plane and normal, and we have a maximum error relative to that point. We also have an oriented bounding box, so if we wanted to take a set of points and place the minimum box that has right angle corners, these would be the 8 corners that that box is defined through. We also do a cone approximation, so there's a point, there's an axis vector, and there's a half angle, and then the area from those points to that cone, and then lastly the same with a cylinder. So that's the multi-point statistics. If you want to clear that, the easiest is just to X out of it and then open it back up, and then you can start selecting things again. This gives you a good amount of information that you can gather from a model, and you can use it for a number of different things. You can also export those points if you want to then do something with this. Now, the trim tool and the split tool are almost exactly the same tool, but the difference is that trimming, as the name implies, it removes an entire section. So I'm going to show that real quick. We can click on that, and then we need to define a plane. We have to define plane tool, and there's a number of ways we can define that plane. So the most common one that I like to use is the parallel option, which means we pick a point and we pick a surface, and the surface defines the orientation and direction of the plane, and it's then translated to go through the point that we pick. Normal is the perpendicular option to that, so we define a line which is then the normal vector to that plane. 3 points is pretty obvious. We select 3 points and the plane will be defined through those, and then with 2 lines it'll use the 2 directions as a way to define the 2 vectors that lie within the plane, and then the intersection or the closest intersection point of those 2 lines as the point. Coefficients is a very direct way, and the angle is you basically pick a plane and you say rotate it. And then we also got the between surface and then from a file. But all of these just basically selected, and then the options presented is fairly straightforward to figure out what they do. So we're going to take the parallel point and surface, and I'm going to just try and trim off this section here. So what we'll do is we'll pick a point and we'll just put it in there, and then we're going to pick a surface, and I'm going to try and pick one that's sort of parallel. Probably this one. Okay, so now we see this plane, and it's got a red and the green pinkish side, a pinkish red side and a green side. This defines which side will be trimmed. So the green side is what's being kept, and the red side, being the alert side, is what's going to get trimmed away. This is obviously not the way we want it, so we can click flip, and you'll see that this side is now green and this is pink. Down here is also a slice preview. That's a very rudimentary way of showing what's inside this section. So if we turn this on, we only get a representation that's basically formed by the graphics card on what's in there, and depending how we rotate it, we'll start to see artifacts outside of that. But it allows us to get a quick view into where it's going to go. Okay, so with this defined, we click OK, and then we have the option of previewing, so we can see what it does. Again, this is the idea that we can see what it's going to do, so that if we don't like it, we don't apply it. So we click preview, it's going to go through, and it's going to show us what this looks like once we actually trim it. Now, in this case, this might be perfectly fine, but I'm going to say no, go ahead and clear it. We actually want to cap these surfaces. So again, preview, and now you see there's a cap being formed on the intersection of this. Generally, this is a robust method, but there can be situations where this cap actually doesn't work, and that's often due to very small errors. So if that occurs, go back, obviously do the preview. If you don't see it, turn off cap surface, apply it anyway and then use the hole fixing tool, and you might find that going through and changing the algorithm will help you with capping it properly. So very simply put, that's the trim body. Now we haven't applied this. Okay, this is just a preview, so we can clear it, go back to the original, and exit out of that without having made any changes. So it's very helpful rather than having to rely on some undo features that basically has to store all the stuff that's being cut away and then bring it back in. This is a preview before you apply to it. The split body is identical in operation. You see the same options provided. So we're going to go in again. We're going to pick a point again somewhere here, and by the way, the surface is already pre-selected, so as soon as you pick a point it switches over to surface, so that speeds things up. Go in here, pick this. Now unlike the trim, this is just a green plane. The reason for it being that we're splitting the body, we're not actually deleting anything. We can go in and we can do a preview, and it shows us this will be one body and this will be a different body. If we do cap surfaces and preview, we can see in there there's going to be a set of surfaces that are being formed to actually close off and heal the intersection. So if we have two bodies that we want to use, it's always important to have solid bodies in the end. So this would be the way we could close this. We can hit apply, and now we have two bodies. Now whilst we're on the subject of individual bodies, we can go in and let's say we did this and we found out, well, actually we don't need this section here. We can simply switch over to bodies, and we can click on this section here, which then highlights, and again you can do control and click to unselect, or just escape to clear all selections. But we can click on this and then right click, which brings up an option, and there's a handful of options here. We can change the color for it, we can do remesh, simplify and thicken operations, which are the ones up here, or we can also say, well, I want to delete this, or let's say we had this one selected in a sample where there's a lot of other bodies. We may say, well, the only thing we're interested in this section here, so we can select this and then delete others, and that'll delete all the other bodies that are in here, and then we're left with this. Now I'm going to go back to the edit tool, and I want to take a quick look at a few of these up here and show what they do. We've already covered the fix holes, we've already covered the issues, but let's take a look at a few down here. For this I'm going to use the monkey geometry. We're going to go in and let's take a look at the normals. So this third tool, invalids, delete any items that are not valid facets. So there might be data defined by means of 3 points, but all 3 points are either the same point or they are on a line, so there's no area, or otherwise collapsed that don't properly define a valid triangle. If we use this option, we can delete those. Split and move and project split are options by which we can heal some of those cases. So if we had facet defined through 3 points, but the 3 points are not the same, we want to maintain that additional vertex, and that means the neighboring facets need to be split at that location. That would be the project split. Split and move is similar, but it provides a motion of that point, so the vertex itself will not be the same anymore. We could go in and can do a preview and then an apply, just like the other tools. In this case, there's nothing to change, and this tool is one of those where you can overdo or underdo it, so I recommend using it with some caution. If you have stubborn geometries, this is one to check out. The multiple is the same thing. It's a very simple tool. It just looks at triangles that are duplicates, meaning it has 3 vertices that are also used by one other facet, and it doesn't matter which orientation they're in. So it'll check for the indices and it'll delete those that occur more than once. The normals is the one we're going to take a look at here. So what we're going to do is we're going to take one of these. Actually, we're going to take both because we can do that. We can select two facets, and then we can do flood expansion up to an angle limit of 10 degrees, which will select these. We can flip them, and then we can accept them. So in this case, it's essentially a reverse scenario where if we travel through the head, we can see that the facets now point inwards. And it's very important that these are oriented in the correct way, because the step file doesn't really know what to do with these if they're not oriented in the correct way. So normals should always be applied in such a way that they point outwards. We can go into the normals tool, and again, it's a very simple option. It automatically determines which direction all facets should point in. And if we click preview, it'll take just a second, updates it all, and we can see now that they're all oriented in the correct way. If we hit apply, we're left with a valid body again. The way it does that, it takes a single facet triangle and uses the overall shape to determine which way it should be pointed, and then it grows from that outwards and makes sure the neighboring facets are not flipped by a large angle. So that's a relatively quick algorithm. Moving on, we've got the merge tool, and the idea of the merge tool is to allow vertices that are in close proximity. So this is a good example here. Let's just set a rotate point here, right? So we can take a look at the inside, and we see this little pyramid sticking out. Don't know where that came from, but that's just part of the data set. Now, in general, this is fine. That's not a big deal. But we might have a scenario where we have multiple points that are very similar, but not actually overlapping. So this is where the merge tool comes in. Now, to use the merge tool efficiently, we want to actually know what these lengths are, and that's where measure comes in. So we'll select the point, we'll snap to existing, and let's just pick this point here, and then we're gonna let's just flip it around. We're gonna select point 2. Again, we're gonna do snap existing, and then we're gonna pick the one at the tip. We see the little XYZ and the shortest line, and take note of the actual distance. So it's 0.003, so it's a very small distance, and this will be in millimeters, so 3.3 microns that would be. Okay, so now let's apply the merge tool, and the merge tool uses vertex distances. So what's the smallest distance to a neighbor? If we leave it at 1 or 0.001, that is actually not the distance to the next one. We have to go as big or bigger. So let's start off with 0.004 and do a preview. Okay, so when we do that, you can see these have been snapped, but because this isn't an iterative approach, so it doesn't snap and then go back and see where the next one's been snapped to, there's a slight offset here for one that wasn't captured. So if we clear it, it is likely that the distance from here to here is actually bigger than this value. So if we want them all to snap together at the common centroid of those points, we probably just have to increase it a little bit. Let's try 0.005. Yep, and that's right there. They all snap together. So that's basically how the merge vertex works. This is a good tool if you have a lot of data points where the triangles are just not lining up quite correctly. Usually that doesn't happen because the application does try to merge those during import, but it can happen that some of those stay disconnected. Now, within this, there's one more option that can be useful. It says only apply to open edges. So let's take a scenario where we still have this, but let's delete out one of these facets. Okay, so now we actually have open edges here. So if we do the merge and only apply to open facets, and we'll go with 4, it does now recognize, whereas before it didn't snap the extra point, it does now actually use those open edges and their vertices to try and snap it. This can be useful in cases where you have a very large number of discontinuities, but you don't want to snap other locations that may be of interest, so you can use the only apply to open edges option to specifically only merge those vertices that are in close proximity and attach to an open vertex. So we're just going to leave that there for now. The last two items in this repair are the overlap and the stitch. Those are definitely on the hit and miss list. Let's zoom out here. By the way, hitting home just recenters and orients the data, so that's often a useful option. Let's say we went in, we split this body, and we picked a point up here and the surface, something like this, and we didn't do cap surfaces and we just applied this. So we can see it's got this scar running through where the facet's been trimmed and so on. The stitch tool allows us to actually stitch these back together. If we do the apply per body, it would try and do this on a per body basis. So if we merge this and this body together, it would still do that. But if we don't merge them into the same data set, then it wouldn't stitch this, it would just not find anything. If we leave it unchecked and do a preview, it very quickly finds these locations and merges them back together into a single body. This is a useful tool in some cases. It shouldn't be overused, just like any of the other stuff. It does have its uses, but for the most part you're probably not going to use this. The overlap is similar in its function, but it assumes that these surfaces are not in a close to touching or anything like that, but actually extend one over the other. It tries to trim them back from that. Where it fails is if the tolerance range is actually too high. It can often end up not functioning in these cases. Alright, so with that being said, we're slowly coming to the end of this tutorial. The things I still want to capture are the wrap and the autofix. Let's look at the autofix first, and we'll just use the original data, and let's go back and do the brutal thing with the eyeballs again and delete these. We go to a limit of 10, we delete them, we accept the data. So in this case the body is not valid for well, you can export, you'll get a sheep body, but it's generally not what you're after. If we just do the autofix, sometimes this is a useful thing to double check first. If we leave it at basic, it will go through and it'll try and do some of these basic tools. In this case it's actually perfectly fine. If we do a preview, it will find these open sections and just close them and say, okay, we actually now have a closed body, which is great in this case. So that's a quick way of doing that. If we go a little bit further and do the extended option, we start to introduce merge options and things like that. So we provided a tolerance, and we can do a preview, and we essentially get the same thing, because it started going through a list of tools to fix it with, and it found a valid solution, and then it stopped. And in this case the valid solution that it applied was the hole fixing tool. Now once you've done one or the other of these, you're getting into these three options, and these can be very slow to process. So I always recommend that if you try one of these, start with a small value just to see what it can do. So resampling tries to take the original data and apply the surface points onto a block mesh, and then tries to reinterpret the original data from that block mesh. So if we do a rough quick view, we can see this actually does a relatively good job in this section up here. The ears, because it's so rough, get punctured, so we could slowly increase this. And we're starting to see that it does actually capture the data pretty well after a certain level. But each size increase makes it slower. The biggest issue with this geometry is that the eye sockets are so deep before there's any data near it, it struggles to find a good solution, and you end up with this channel that's on the inside. So even if we did increase the sample size, and I recommend not generally going above that unless you're sure and you may not need the application for the rest of the day. If you're seeing issues at this level, you probably don't want to go further. So we'll leave it at that, but you can see what this does. It tries to reinterpret the data from an original set. Solidify is somewhat similar to the resampled, but it goes a step further in that it also attempts to create what's known as a smooth sign distance function to the data. So again, start low, use a very rough cell count first. Parameter of 0.5 is acceptable. That's the one I recommend. Essentially goes from 0 to 1. So 0.5 is sort of a good balance between trying to be inside and trying to be outside. That's really what it refers to. So we can see in a preview what this looks like. And here it does actually manage to fill these in. Again, everything is so rough, but we can see there's some possibility of gaining a solid body out of this. We'll step it up one more, and Solidify is a lot slower than the resampled option. That's why resampled exists, because Solidify is a slow moving process. So just a few seconds and we get this, and to me this would probably be a relatively good starting point for maybe doing some manual cleanup. You can see some of these facets are overlapping. Probably the easiest would be to delete them and then either using a hold tool or a manual process to fill them in. This is at cell 64, so what I'm going to do is I'm going to try the 128 and I'm going to apply it, and then I'm going to basically cut the video when it's done. Okay, and that took about 4 minutes, and this is the result. So you can see there's definitely better representation as far as the overall body is concerned. This tool may get a little bit more attention in the future, just to see if there's a way to make the algorithm faster. For now, it is what it is. So it's a useful option in some cases, but I wouldn't rely on it too heavily. The main point is to start with a rough model and slowly work your way up. If you picked 512 right away, that's basically each of these is a step 2 to the power of 3, so 8 times longer. So if, let's say this took 4 minutes, this would be over half an hour. And then this would be several hours to compute that. So keep that in mind. Changing the parameters basically would make the eyeballs bulge out a little bit or bulge in more. I believe if it was 1, it would be a sphere popping out, and 0 would be a sphere popping in, concave. But lastly is the voxelize. This is an interesting option. It does pretty much exactly what the name implies. It turns this into a voxel representation. That might be interesting for other purposes, not necessarily as a way to tool it, but I'll show this anyway. Again, we'll do the rough approach. The same parameters are up here, applies down here. So let's take a look at that. So that's 32 cells. This is, yeah, I guess Minecraft comes to mind. 64, a little bit more refined. We're starting to see the actual body being determined again in this way. And then I'm going to pick 128, and I'll do the same as before if necessary. So this took about a minute. It's definitely faster than the Solidify. And you can see this an interesting representation in terms of voxels. It does essentially the same thing as the Solidify, but the data that's being generated in the Solidify is then just kept as actual voxels, meaning boxes at a vertex location, without trying to recover some of the original surface from that. So it's an interesting way of looking at this. Maybe this is a tool in and of itself. I don't know. People might have fun using this. Don't jump to the very fine and fine options right away. Those would take a very long time to do that. So let's assume you used one of these tools and it came out okay. It's same as before. You hit apply and you make that a permanent feature. So I'm going to close this out though. Let's take as a last tool, we have the wrap tool. That's also in the automatic options. These here try to take existing data and fix little bits and pieces where they are. The wrap and the auto fix try to approach it from a holistic perspective and use not the individual components but the overall shape and volume, and the wrap is very much in line with that. So we have a number of options here. Again, we can use only point normal data, and what this effectively does, it converts the faceted data back into a point cloud. It's sort of reverse of what we saw in the import video. If you haven't seen that, maybe take a quick look. But it generates a point cloud from the data, and then it tries to recreate the data from those point clouds. So it's an interesting process in that it actually completely removes the underlying data that we already have. The sample sets define the voxel size within those algorithms. So again, I recommend going smaller just as a preview, then you can always work up. So we'll do a preview of 32 samples, and you see the algorithm internally generates a reasonably good representation. If we do 64, that's going to be definitely more realistic, and as you work up you get more facets and therefore better representation of the data. As it is a point cloud method, you'll see regions where it's well defined through those point sets, and others where it starts to break down along essentially an octree method into finer data. If we don't want to do this, we can turn that off, and we can use an internal algorithm that does something relatively similar, and you can sample the data and then you can create a mesh around it with a higher or lower resolution. So what I generally recommend is start both very small just to see what that looks like, and then start increasing the mesh resolutions, and then at some point you'll get these artifacts. So in this case it's very quick actually, where the mesh suddenly grows outside of the original sample set. So you have to start increasing the samples to remove that, and here you might start to get to a level where you can actually use the data already. And there we see again the mesh divisions are too high. Increase the sample rate and we're back to having a relatively good data set. So from my perspective, this would probably, if I didn't have the data and a way to fix the holes, this would probably be a good way of quickly recovering that surface if the underlying data was so bad, so jagged or whatever that I couldn't use it. We'll do just one more, and we know it's probably going to need both set. And that was actually relatively quick, so I cut the video real quick. That was probably about 30 seconds processing time, and this would be a decent body that we could use for further refinements and things like that. It has closed up these sections quite well with something that doesn't suffer from the original sort of instability in the eye sockets. Obviously if we can just close the hole, that's the ideal way, but these are another option. Now, lastly, there's one tool that's actually quite interesting that I like, and it's the shrink wrap within the wrapping option. And maybe not quite obvious, shrink wrap actually means it creates a box that goes around the entire geometry, and then it starts to reduce that onto it until it finds something that um, suitably defines the data. If you leave edge length at -1, it'll use the first iteration to go back to the original data to try and figure out what a good number is. And then iterations is literally how many times it'll try and shrink down to that data set. So if we leave it at edge length at -1, so automatic calculation, and do a preview, we'll cut the video real quick and we'll jump back in once we have data. So this took about 30 seconds, actually relatively quick. You can definitely tell that it's not quite down to the original body. There's still some amount of extra space that's being added to this, as if, again, if it were shrink wrapped onto it. And it's given us an edge length of 0.021, and that is actually these characteristic edge lengths here. We have ways to refine this and make it cleaner for the places where it's sort of jagged, but in general this would be a suitable size. If we do more and more iterations, obviously it's going to take longer, but we're actually going to start approaching the original surface a lot closer. We can get almost to the point where it is the same surface, but it does take a lot of iterations to do that, so I just want to warn about that. So I'm going to do 100, and I'm going to pause the video, and then we can see what that looks like, and we'll just set this as 0.02. So after 100 iterations, this is what we end up. It's not perfect, and it looks like a chunk here actually over collapsed. Not quite sure what that is. It might be that the edges themselves actually got too small and started growing inside of the body, so that would have to be investigated closer. This took about 5 minutes, just for reference. Smaller edge length obviously will take longer. We can make this really big, and it's probably really quick. Yeah, we just get a blob. So it's an interesting tool to use. It can be obviously misused. Don't use as a way to guarantee something. But if you have loose data that you want to tie into a body that you can use for something, this is almost a last resort fallback that you can just shrink wrap it into coherent data. And that pretty much covers everything on the edit tab. There's not too much else. One thing to point out is when you do low level edits, so deleting stuff, the only thing you can delete are facets. Both edges and vertices are only deleted during export or import because there's no valid data associated with an edge in terms of STL files anyway. And also for people that work with this on very large and very complicated models, or ones that have a lot of changes that need to be applied, my recommendation is you import it, you make small changes or even big changes if you need to, and then occasionally you save as a backup. And when I say save as a backup, there is no internal format that will expedite this. This is really based around the STL format. So the best you can do is make your changes, then go export and write it as a STL file, you know, and it will be by default a binary STL file. You can also write it as an ASCII. Binary is actually both quicker and more compact, so I just recommend as a default, and it'll tell you, yeah, it saved the entire thing in 0.03 seconds. So if you then need to go and open it back up, it's right there. And in this case, yeah, during import it said, hey, this is not a manifold solid. So I do recommend the exporting of files frequently. Whenever I work on a project, I export several times, especially if I'm making a lot of edits. I like to do set of changes, save it, sometimes just re-import it as well, just to make sure data is cleaned up again, because like I said, vertices, edges are not deleted in delete operations. So keep that in mind as a helpful work option there. And that's it, and we'll move on to the bodies tab in the next tutorial.